This is 9.1 on solving equations by taking square roots. So we all know what square roots are, correct? What is the square root of 36? 6, right? Yeah. We can also break down the square root of 36 by saying that 36 is equal to 9 times 4. So that becomes square root of 9 times square root of 4. Square root of 9 is 3 times square root of 4 is 2. So 3 times 2 is 6. That's just a long way. I just wanted to show you guys that if I have something like square root of 45, we can simplify this by saying that 45 breaks out to be 9 times 5, right? And we can say that the square root of 9 times square root of 5. So the square root of 9 is 3 times square root of 5. We don't really need the times anymore. So 3 square root of 5. So the 3 square root of 5 would be the simplest form of square root of 45. Okay? From here on out, I need to see this. All right, you guys need to simplify it down so that it's to the simplest form. All right? Same thing goes with division as well. If we have something like the square root of 16 over 100, the square root of 16 over 100 can go 16 over the square root of 100. What's the square root of 16? What's the square root of 16? 4 over square root of 100? 10? Okay. Which we can break that down into 2 over 5. Right? Okay. So what we're going to do here, right, is we're going to solve equations by using this skill. Okay? So your first example here is going to be 4x squared minus 5 equals 2. Okay? So how we're going to solve this is we are going to add 5 to both sides first and try to isolate our x squared. Okay, so we're going to add 5, add 5. So we're left with 4x squared equals 7. And then we can divide by 4, divide by 4. So we're x squared equals 7 over 4. And now how do I get rid of the square root? What is the inverse function to squared? Or how do I get rid of the squared? How do I get rid of this 2? What's the inverse to something being squared? Square root. Okay? We all know that. Let's talk about inverses for a little bit. Okay? We all know that the inverse operation to addition is subtraction, right? The reason for that is, let's say 3 plus 2, that equals 5, right? And then 5 minus 2 equals 3. So you guys see that I started off with 3, right? I added 2 to get 5. From here, how do I go back to 3? I have to subtract 2. Okay? That's why they're inverse operation. Or that's why they're inverse, operations. Okay? Same thing goes for a multiplication and division. Okay, so if I multiply something by, let's say I multiply 5 by 4, right? I got 4 times 5, which is 20, right? I started off with 5, correct? So if I go with 20 divided by 4, that becomes 5. Okay? So 4 times 5 gets equals 20. 20 divided by 4 gets me 5. So where I started, I basically ended up. Where I started, I basically ended up. Okay? That's what inverse means. How do I get back to my original spot? Basically. Right? So if something is squared, let's say I square 3. Okay, this is my original spot of 3. Okay, that's my original number. I want to get back to 3. 3 squared equals 9, right? So if I'm at 9, how do I get back to 3? Divide by 3? Yeah, you can divide by 3, but that one's kind of like a bad example. So let's start off with 4. No. Yes, you can divide by 3, but you're actually just gonna square root the 9, okay, to get back to 3. If we start off with 4, 4 squared equals 16. The square root of 16 equals 4, okay? So the reason why square roots and not um, division is the inverse operation here is because we have to do something with the squared, okay? Just like how we added 2 and we subtracted 2, just like how we multiplied by 4 and we divided by 4, the inverse operation is we have to use the same number. We can't use different numbers, okay? So notice what I'm saying is, notice that here, if I wanted to get back to 3, I would divide by 3. Here, if I use division, I would divide by 4. They are different numbers, right? That's not how inverse operation works. You just got to use the same operation all the time. Okay, and the operation would be square rooting it instead of dividing it. Okay. So here, going back to my first example, in order to get rid of the squared, I would square root it, right? So x is going to equal the square root of 7 over 4. Okay? But since this is squared, right? And if you square a negative number, it becomes a positive number anyway. This has to be a plus or minus. It's always going to be plus or minus. Because if x squared equals 7 over 4, right? Then I can put in a negative 7 over 4 squared the negative squared becomes a positive, and then the two square roots just cancel out, right? So this would also be 7/4. Okay? Let me highlight this part of it with an easier example. Okay? If x squared equals 49, okay? I can square root it, and this would become x equals plus or minus square root of 49 is 7, right? The reason why it's a plus or minus is because I can plug in negative 7 squared. What is negative 7 squared? Negative 7 squared breaks out to be negative 7 times negative 7. What is negative 7 times negative 7? Positive 49, right? And if I just have a 7 squared, I know that's also 49. Okay, so both the negative and the positive gets me a value of positive 49. That's why you put the plus and minus in there. Okay? All right. Let's go with another example. 2x squared minus 8 equals 0. Okay, so here I'm going to try and isolate my x squared by adding 8 first. So it's 2x squared equals 8. And then dividing it by 2 on both sides. So x squared equals 4. And in order to get rid of my squared, I square root it to get x equals plus or minus 2. Okay. Questions on that? No, right? Fairly simple. Okay. I want you guys to try these two. Example 4 and example 5. 3x squared plus 6 equals 33. And 5x squared minus 9 equals 2. Okay, so try these two guys, 4 and 5, and we'll be back in a little bit. Okay, so here we would subtract 6 on both sides first to make that 3x squared equals 27. Divided by 3 on both sides. You get x squared equals 9. Square root both sides to make that x equals plus or minus 3. Okay, we do need that plus or minus, so please do not forget that plus or minus. Okay, here on number 5, we got to add 9 to both sides. So 5x squared equals 11. Divide by 5, divide by 5. X squared equals 11/5. And then I'm going to square root it. Square root it. X equals square root of 11/5. There is another step to it, but I'm not going to. Don't forget the plus or minus. I'm not going to cover it. So this I will accept for now. Okay, as your answer. All right, we're good. Okay, now there's a different type of problem that we have to cover, and it's when you have a perfect square binomial, meaning you got something like this. X plus 5 quantity squared equals 36. Okay, like that. What do I get rid of first here? I want to isolate X, right? My answer is going to be X equals something. So what we're going to do here first is we are going to square root both sides. Okay, when we square root both sides, this square root cancels out with this squared to make X plus 5 equals plus or minus, what's the square root of 36? 6. And then what we can do is subtract 5 on both sides to make X equals -5 plus or minus 6, right? So there's two answers embedded in this equation, right? There's a -5 plus 6, which gets me 1, and -5 minus 6, which gets me -11. Okay? Quick question. What do these represent in this quadratic? So my question is, if I solve x equals for x, if I solve for x and I get 1 and -11, graphically, x equals 1 and x equals -11, what does that represent? The x-intercepts. Okay, so you know graphically that 1 and -11 is going to be my x-intercept. Okay? What's the midpoint between 1 and -11? You don't even have to do any math. You can look at the equation itself. What's the midpoint? Or you can do math and figure it out. What's the midpoint between 1 and -11? -5, right? So here lies my axis of symmetry. Okay? And look, guys, my original equation, let me just put it here so I don't have to go back and forth, is x plus 5 quantity squared equals 36, right? The 5, if you think opposite, that's -5. That's my vertex, right? That's my h value. Okay? What's my k value? What's my k value then? It would be negative 36. Yeah, because this, if I put this on this side, my k value would be negative 36. So x minus 5 quantity squared minus 36 equals 0. It's negative 36. Okay? All right. But that was just a little extra for you guys to think about, because they're all of these ideas that we're covering in this class, they're all interconnected. Okay? So 3 minus 5 quantity squared equals 18. What do I do here first? What do I do first? Divide by 3. Okay, and then the steps would be the same, right? As before, x minus 5 quantity squared equals 6. Square root. So x minus 5 equals plus or minus square root of 6. Do not forget that plus or minus. Add 5 to both sides. And you're left with x is equal to 5 plus or minus square root of 6. And that is where we'll leave it. Okay? Questions on this? Last example for today. 2 times x minus 3 quantity squared equals negative 32. Okay? What do I do first? Divide by 2. Divide by 2. So I got x minus 3 quantity squared equals negative 116. And then I would square root both sides to get rid of the squared. X minus 3 equals plus or minus square root of negative 16, right? Questions? Yeah. No? Any questions up to now? What is the square root of negative 16? Yeah. 4? Negative 4? If I put the square root of negative 16 in my calculator, what does the square root mean? Two numbers, right? Or one number times itself equals that number, right? Does that make sense? Right? Something along those lines, squared and square roots. Is there any number that gets me, if it's multiplied by itself, gets me a negative? No. Right? There's no number, because a negative times a negative is a positive, right? So if you think it's negative 4 times negative 4 equals 16, positive 16. 4 times 4 is positive 16, right? There is no number here that gets me a negative number. So that's why even if you put it into your calculator, you get error, domain error. That means that it's not possible. Okay? So whenever you come out with a question like this and you see that negative inside my square root, stop right there and just put No solution. Okay? Because there is no solution. All right? In this class. Cool? In integrated 3, when you reach that point, you'll learn about imaginary numbers, but in this class, we will not. Okay? So it's for now, it's just no solution. Cool? Or no real solution. All right, and that is 9.1 on solving equations by taking square root.